Hello and welcome to this section. In this section, we will learn about things. This section mainly includes the following contents. First, we will learn the definition of things, then we will talk about the use scenarios of things, and then we will introduce the use methods of things. Finally, we will talk about the principle of things and some of the costs it will use. First, let's introduce the definition of things. The so-called things are a collection of a series of database operations. Multiple database operations can be combined into a unit. As long as one of them fails, the whole execution string can be rolled back to ensure the consistency of data operations. For example, we define the following series of operations. When a transaction starts, we ask it to perform a submission operation of database 1. If it succeeds, we then ask it to perform an update operation of database 2. If such an update operation of database 2 fails, the operation of database 1 will be performed automatically rollback. Similarly, if database 2 succeeds, he then performs an update operation of database 3. If an update operation of database 3 fails, the update of database 2 will be rolled back, and the commit of database 1 will also be rolled back. In other words, for a thing, the success of the whole thing can be counted only if each step is successful. As long as any of these steps fail, the thing will roll back to a starting state of the thing. Then let's talk about the applicable scenarios of things. Generally speaking, the most commonly used scenarios of things refer to those with high concurrency and high requirements for data consistency. For example, here we do an online second kill activity. There are a total of 10 second kill products in our database. When the user completes the second kill, he can obtain his payment information, and a second kill information submitted by him. The second kill activity may be used by thousands of users at once. If things are not used in this scenario, it may lead to more than 10 users successfully paying and submitting purchase information, and this problem can be effectively avoided in the case of wrong use. Therefore, in the scenario of high concurrency and high requirements for data consistency, we all need to design a service through things. Next, let's learn how to use one of our things. In the same way, we should first open a case of an address book we made before. When we select Backend, we can see that there is an exclamation mark around which is a rotating symbol. This is one of our things. When we select the backend, we can add a thing by clicking. Similarly, we can easily add a thing in our logical operation bar. When we select the wrong one, we will find that it has a receive parameter, a return parameter, and a definition of a thing. It is very similar to what we add. Is this almost the same as our service? It also has the ability to accept parameters, return parameters, and the beginning of a service. Therefore, from a certain point of view, our use of things is almost exactly the same as our use of services. Therefore, we only need to know how to design a service, and a little understanding of things we can complete a design of the logic of things. Here I will make a condition for you. For example, we have an address book here, and if I use a statistical sum every time, the performance may be very poor. So here we add another such database in the backend, which is called make a total. Here, let's make statistics on the compliance data in the database. For example, it is called the number of people in an address book here, and then we change it to a field of an integer, and then click OK. Here we directly add a row of data. For example, in this address table, 123 has the only status 3 pieces of such data, so we first give it a default value, which is equal to a 3, and then click 1 to save. Of course, the default total number of people in an address book here is equal to 3 because we calculate it here. When I complete a data submission here, should I also change the total system value from 3 to 4? So here, let's rewrite the logic of such a submission through things. Shall we change it to a data submission? Similarly, for data submission here, we also need to get a user's name and a user's phone number. Therefore, for a transaction here, we also add 2 receiving parameters, one is our life and the other is what. It's one of our calls. Then, similarly, we still talk about a series of parameters here, which can be directly put here, for example, whether it is successful, and then, for example, the reason for failure. Another is our submission result. Is it a writing method that is almost exactly the same as that of our writing service? Similarly, we select things here. We use top-level things to perform an operation on our database, so here we select a communication table and click a submitted operation. His name is equal to the name in our drop-down menu, and his phone is equal to a phone in the drop-down menu. His status is equal to 1. I feel almost the same as our service here, exactly the same, right? We then select such a submit action. We click a callback, and you can see that there is a method of completion, success and failure here. Let's write it here according to a very standard method. What should he do when he successfully submits? If he successfully submits, can we then update our total amount? Let's complete an update here. Why? Let's add such a transit process here to assign a value to our submission results. The content of assignment is an object variable of the result submitted by him. Similarly, a successful submission has been completed here. Therefore, the result submitted here is a value of the result submitted here. What is the set we do here? They are all successful cases. If the submission fails here, what should we do? Click a callback here. Then, when the submission fails here, we will select the current thing from the drop-down menu. Instead of selecting a return result, the following is a rollback transaction. What is the meaning of rollback? It means that everything done in this thing is restored to its original state, so whether it succeeds here is a no, and then the reason for failure is a reason for the failure of our submission of results. Did you let him give a feedback here, and then similarly, did we add a callback? Similarly, if it failed, when the pre-transaction is not to set the feedback result. It is a rollback transaction. It is to roll back a piece of data submitted in this way to ensure the consistency of our data. And what is the success here? What is one of the reasons for its failure? Is it a failure reason to update the result? Has it completed a definition of our whole thing? Therefore, for us, the biggest difference is that in the case of our failure, we can select a rollback transaction on our side in the drop-down list. When he executes the rollback transaction, the data in the whole transaction will return to his original state. Of course, I wrote a lot of conditions here, such as what to do after success, and what to do after failure. For our things, if his real submission fails, he will automatically help us roll back the system. In fact, even if the cloth shoes on our side are rolled back after they fail, it will automatically roll back. However, the rollback on this side will not help us bring a series of reasons. Therefore, if we want to make a production with detailed logic, we still have to distinguish between success and failure. Come on, when to let things set the return result, when to let things go back to a country, write it clearly, so as to have a higher readability. After defining our things here, how do we use our things next? Then, please note that when we click Add, we can call a thing submitted here, right? Let me show you. Can I choose one of our data submissions directly? No, why? Because for our things, what is it? It is a back-end action. What is the back-end action to use for a call? Is it through our service? So here we actually change our added service to use it. Our added service calls one of our submitted things. Then one of his name is equal to the name we submitted from front end. His phone number is equal to the phone number we submitted from front end. When he finishes, the same thing should be done. Wait, the current service area sets the return result, and then the return result here is actually the success of a return result transaction, a failure reason of the idea of things, and a submission result in things. So we can delete this here, so pay attention. What do we do when we want to execute a thing? We need to make a call through a service, so generally speaking, we can put such a thing under our service to facilitate its classification. Okay, let's take a look at the preview. For example, let's have another one here, and then type in the phone, and then click one to add. We can see that the data here has also completed one addition, so we can see that the total amount of our data has not changed into 4 categories, because there are 4 such numbers in 1234 and in our address book according to the, so its total amount has also completed 1 plus 1, and the total amount of an address book in such a database will be strongly consistent with our total amount. Similarly, the data deletion here is also consistent, because when we complete a data deletion here, should we also let one of our things update a data here? So here, we will also complete the production of the deleted thing. Here, we will add another thing called a data deletion. Here, we can directly copy the service, and then paste it in the data deletion. Then, in the same way, we need to get a data ID. Our receiving parameters are also our data ID, then its return parameters are still the same. The return parameters here include our success, failure reason, and update result. In the same way, this is also an operation to update our database. If it is in a successful state, why? Do you want to update the value in our total amount? So this is also an operation to update a piece of data. Here, its data ID is equal to the value of 1. What is it? What is the number of people in its address book? Do you want it to perform a simple operation by adding 1? To change the maximum number of updates here to 1, and then add a callback. What if he succeeds? At present, the Bureau of Affairs sets a return. The success of the result is equal to a yes, and then there is no reason for failure. Of course, this is a deletion. If it is deleted, the update result of cloth shoes is also okay. Then, in the same way, we add a callback here. If it is lost, what should we do? Is it necessary to roll back the current transaction? Whether it is successful or not, there is a no here, and then the failure reason is a failure reason for our update results. Then, if the update fails, the same thing here is to select a rollback transaction, and then whether it is successful or not. Then, one of its failure reasons is a failure reason of the update result. Therefore, in fact, we should follow a logic here, that is, if it is really successful, we will let it continue to perform the next database operation. If the next database operation is successful, we will let the current transaction set its return result. If its next database operation fails, we will perform at the current transaction in the row drop-down menu to roll back one of its transactions. So for us, only if it succeeds, we set a feedback result. For all failed branches, we choose to roll back a thing. Okay, the data deletion here is also defined. Then what do we do? Can we directly use the data deletion in a thing here, and then the data ID is equal to the submitted data ID, then, when it is completed, the update result is returned through our current service area settings, which is an update result of the returned result, and then success is the success of the returned result. The failure reason is one of the failure reasons in the returned result. Is our deletion done? Let's check. When we have a reading, there is one squatting here. We delete the squatting, and you can see that the squatting is gone. Let's refresh it, and you can see that one squatting here is gone. Then there are only 3 pieces of data in the database. Then let's take a look at the total number of people in the database. Therefore, this is the best way for us to ensure the strong consistency of data. When we update the status of one data side, the other database will also maintain strong consistency and update one data. Then some students want to ask, saying that there are so many advantages in looking at things, which can ensure such strong consistency of data. Why don't we use mistakes to make a production under any circumstances? Here, I would like to introduce to you that in HiCode, the operation of common services on the database uses the mechanism of separation of reading and writing. In our backend, there is a special writing strength and end reading strengths. All reading operations are unified through reading examples, including our output statistical classification, and the writing operation is unified. Through our display rate, we include our submission and import and updates, etc. The biggest advantage of read-write separation is that it can improve the operation performance of the database, because usually the number of requests for read operations in the business will greatly exceed that of write operations, and the mechanism of read-write separation will bring a certain amount of data delay. For example, if the data just submitted is output immediately, the data we just submitted may not be output. Because the synchronization between the write library and the read library takes about 20 milliseconds. See a document about the read-write separation mechanism for details. However, since the consistency of data must be strictly guaranteed, when we read in the thing, it will also be executed in the write instance. So for example, we just submitted a piece of data, and then immediately said that as long as the two operations are in one thing, we can immediately obtain the data just submitted, without a delay of 20 milliseconds. This feature simplifies a design of our database operation, but because the read operation is also realistic, it will lead to the back-end computability of database things. The energy consumption is also relatively high, so we can't take advantage of the benefits brought by the read-write separated distributed database. Translation is the use of things. The back-end calculation will be more expensive. In addition, when we use things, we can also lock the data. When we update a row of data in a thing, the database will automatically enter the single queuing mode. In order to avoid the problem of data inconsistency in high concurrency, the processing of anything is a single series, that is, after a thing is processed, it is involved in the transaction. The row that arrives will be unlocked and let the next thing handle it. This method ensures the consistency of data, but at the same time, it also causes the processing of things to be slower than that of ordinary services. Finally, I will remind you that there is a time limit for transaction processing. At present, we limit it to 5 seconds. If too much processing content is processed, it will lead to a failure of triggering. Finally, a prompt will be given. That's all the content of this section. Thank you for watching.